Next up, we will have our panel discussion titled How Connectivity and Data Processing at the Edge Drives an Efficient Future. This panel will be moderated by Dave McCarthy, Research Director of Edge Strategies with IDC. Dave is joined by Wael Gubin, Laura Wan Ambassador with LoRa Alliance, and Deepanjan Paul, former application developer of 7-Eleven. Dave, take it away.
Thanks a lot, Sean, and welcome everyone to this panel discussion. My name is Dave McCarthy. I'm a research director at IDC. And for those not familiar, IDC is a global market intelligence and advisory services firm serving the tech industry. So, here we are now, partway through today's discussion, and it's you start hearing more and more sort of emerging themes around, why are we all getting together around edge computing? And it's interesting in the fact that you hear many speakers sort of reinforcing sort of the same things that, edge computing in some ways has been around for a while. Like the last speaker talking about, Akamai and CDN networks. In some respects, this idea that, we never streamed YouTube videos directly from Mountain View, California. There was always a distributed network that did that. And that distributed network is moving from even distributed data centers out to devices themselves. And so when I think a lot about edge computing and IoT, there are, in some respects, sort of the two worlds. One is, how do you take the things that we have been doing and do them in a slightly different way? And the second is all of these kind of net new sort of use cases that are in many cases being driven by IoT, like devices in new places doing new things. So for today's discussion, we want to talk a little bit about, connectivity and data processing at the edge, some of the things that it does. I do have two very respected speakers on the phone, and I'd like to give them a chance to introduce themselves. So, Wael, why don't you go first? Tell me a little bit about who you are and the types of things that you're doing in edge computing today.
Thank you, Dave. Hi, everyone. Good morning, good afternoon. My name is Wael Gubin. I am Director of Wireless R&D and IoT at Charter Communication. And I am also for the LoRa Alliance. I am the marketing committee chair, and I am an ambassador for the LoRa Alliance. I think it's actually a subject that really passionates me. I would say edge computing. When I try to think about the two topics that you started with, and actually I have to say I tend to agree a lot with what Michael was saying a little bit earlier, and to kind of to talk a little bit about connectivity and processing. I think in terms of connectivity, there is a need to understand first what types of connectivity are actually good for edge computing and what actually the ones that we can use. So if we think in terms of short, medium range, I would say BLE, Wi-Fi, Zigbee, these type of connectivity solutions will be helpful because their architecture and the way they convey data is apparent actually to an edge compute. If we try to also think about the LP1 space, I tend to think that in the LP1 space there are a lot of contenders like LoRaWAN and Sigfox and NB-IoT, but the one that would really kind of outstand in these connectivity solutions would be LoRaWAN, because with that connectivity you're able to kind of create what we call a network in a box, literally, and you have all the functionalities of a core network and the core, I would say, of your network at the edge, and you'll be able to process, to store, and to convey all your data to kind of a local edge and a local processing point. Also, if we look at the kind of wireless broadband technologies, things like looking at this, for example, the CBRS spectrum and the private LTE, private 5G, that's also a piece of technology and a piece of kind of wireless communication that can help us scale kind of edge compute and edge, I would say, devices. And the fact that we can run these private LTE, private 5G in the CBRS spectrum within, as well, as I was saying, a network in a box where you have your EPC, your eNode B, everything co-located with your factory or with your kind of the use case that we're trying to solve, that helps as well kind of bring data and bring processing actually closer to data and on premise. This is, I would say, more to kind of cover the the connectivity solutions, as you kind of spoke about earlier. And in terms of kind of processing at the edge, I want actually to kind of distinguish two things. One is the true edge, like where really and literally data is being generated. You can think about that like a temperature sensor, a vibration sensor, a LoRaWAN sensor in like somewhere that's generating data and processing it locally, and making decision locally, like literally where the data is being generated. And the near edge, where we can talk about like a local, close to data, close to devices, kind of processing entity that can be, again, like network in the boxes, as we said, and that for that we need to scale compute and storage and make use of these connectivity solutions as we talked about. I'll stop here, and we can talk about all this, I would say, more into details, because otherwise I'll be going on for like hours on this.
Yeah, well, obviously your passion comes through, right? And I think that's what's
Thanks.
exciting about it. Dipanjan, I'd like to hear a little bit about what you've been doing in edge computing.
Hey, hi, good afternoon, good morning, wherever you are. So I was working in 7-Eleven, and I'm a software engineer. So basically, as you can see that I'm not an IoT guy, but now the trend has somehow moved me to work on these IoT devices, shifting from my regular software work. So I worked in the 7-Eleven project of cashless store, in which we used a lot of IoT devices, and especially the point which former speaker told is about the edge computing, the need of edge computing. We really felt in our project that we could have further improved and superfine when we give more intelligence to the edges, so that the network is used whenever required, rather than just bluntly pushing all the data on the network. So that's all. It was.
Yeah, great. Thank you. And for people watching, we're going to continue this discussion, but towards the end, we will have some time for Q&A. So as we're going through these discussions, feel free to put some questions into the box, and we'll circle back towards the end. So, well, I want to ask you, going back to you, because one of the things around connectivity that you hear is that there's many different ways to do it. And certainly, when I look at what's getting a lot of media and press, is 5G, right? Everybody's excited about 5G and what it can do and the use cases that it's for. But you, representing the LoRa Alliance and LoRaWAN, it's meant for completely different types of use cases. Can you help people understand, what are the characteristics of LoRaWAN and when you would use that for IoT versus something like 5G?
Thank you. No, that's a great question, actually. And I wouldn't, to start with, I wouldn't oppose actually 5G to LoRaWAN. I tend to think about them like as complementary solutions. So you have, or kind of complementary technologies. So with 5G, or actually realistically what's being kind of deployed, which is like a faster version of 4G today, you have the fastest, the greatest, I would say, to kind of move data around extremely fast over the air, in a kind of a time-sensitive way, and that kind of for mission-critical applications. And on the other end of the application spectrum, you would have devices that we would deploy in the billions, literally, but that need a very kind of a low-power communication, long ranges, kind of low-power operation devices that will kind of wake up every now and again, transmitting a kind of a small payload to the network. And these use cases are the most, I would say, kind of served by LoRaWAN as a protocol. But first of all, actually, let me maybe take a step back to what LoRaWAN is. So for the audience who is not familiar with that, so LoRaWAN is a low power weight area communication protocol that's being standardized within the LoRa Alliance. The work that we do in the LoRa Alliance is about how do we make sure that we are building a secure, scalable architecture of networks and definition of a protocol for the layer 2 plus, like the MAC layer, the networking layer, and even kind of the transportation of data between devices to gateways to network servers, and network servers to application servers. So we're addressing kind of the full picture, and we're basing our kind of MAC protocol on top of a very solid physical layer that Michael actually addressed and talked about a little bit earlier in his presentation, which is the LoRa physical layer. So that's, I guess, for the LoRaWAN piece. And as I was saying, so it's mostly for low power weight area networks. We're talking about ranges in the miles compared to kind of hundreds of feet, or like for like the traditional cellular and the traditional, I would say, Wi-Fi type communication. LoRaWAN is meant as, again, for the delay tolerant applications, low power operations, smart metering, for example, smart cities like in parking management, smart agriculture. So all these are verticals where you have like sensors kind of sensing a physical property, or kind of reporting on a physical property, and sending in a very kind of asynchronous way, like uplink heavy compared to a downlink. Small amount of data every now and again over long ranges with constraints of battery and power constraints.
Yeah, I appreciate what you mentioned, and it's easy, I think, in all the things that we do, is when there's something new, the first thing is somebody says, "Oh, so is this in replace of something else?" And more often the answer is no, it's a complementary kind of thing.
Exactly.
And and the reason why I asked you about that difference between 5G and like LoRa is because there's been some news stories recently around some of the 5G providers telling people to turn off 5G on their phones, for example, because of battery drain. Because it does require a lot of energy. And when you look at those examples you mentioned, like a water meter, that's probably battery based. I mean, could you imagine what you would do? This is an example that would be perfect for something like LoRaWAN, right?
Absolutely. And back to actually just a small comment on that. So the SLA, for example, the service level agreement you'll have on a water meter or an electricity meter is, again, we're talking 10 to 15 years on batteries minimum, and these are not, I would say, especially here in the US, as you might know, these are kind of things that are buried sometimes underground, and that it's not easy to replace batteries or even charge batteries on these devices. So that's where we think the LoRaWAN play is, compared to the kind of high throughput networks where 5G and private LTE, Wi-Fi 6 will have a great play, actually.
Yeah, perfect. So Deepanjan, I wanted to go back and talk to you a little bit about the example you were giving with 7-Eleven, because my understanding is this was, in a lot of ways, a move towards a cashierless store, right? So it was an injection of new types of IoT devices. And so part of this, I think, was a scale sort of thing. Like, how do you, I'd like you to sort of address two things. One is, what did this look like from a scalability perspective? Like, how many sensors and what type of data are you generating? And then the second part of it is, what challenges did you run into from a security side of all that data collection and generation?
Okay. Yeah. So answering your first question, we had, when you talk about scalability, when we started with a POC around with 10 cameras on top and weight sensors, so maybe one rack only, it was working fine. But when we went to production, so it expanded from 10 to 65 cameras. So they were all Intel cameras, overhead cameras, generating a lot of depth data also. They were all depth cameras. So I would say that the data generation was huge, but at the same time, the weight sensors were sending the data all the time to the Fusion server where we take the decision. Now, what I could feel that if someone is not even walking in the store, those data were still getting generated. The weight sensor was sending the data, though it is no difference in any of the shelves, as well as the depth cameras were all capturing every zone and sending it to the. So somehow I feel that we need to put some intelligence on the cameras part, as well as on the weight sensors. We later on the software part we did, when there was some difference, then only we send those data to the main server. But from the camera point of view, right now it was capturing everything when you switch on and switch off. So we need to put some sensors, PIR sensors, or some motion detectors. When someone is in his zone, then only capture the data. So this was generating huge data, and we had to filter out the irrelevant data, and then just, it was more of a, it's like 80% data was not needed, only 20% data was used. And now coming to the second question, the challenges. The first challenge, when we did the POC, we were using, of course, Raspberry Pi and all those stuff. It was a quickly you can prove your concept. And now when we went for production, the first thing, the security, the network people came and said that you cannot use Wi-Fi. So then we thought of using this LoRa thing also, because each shelf we needed, it should be able to transmit the data. And we, as the practical problem, we cannot keep on charging those sensors or replacing every day. It means you have to empty the shelves, take out, recharge, which is not possible practically. So finally, the LoRa was a little bit expensive on that part and not tested at that time. So we went for and the time constraint was very critical. So we went for wired communication. We had to wire everything to the wait servers. And so the cameras were also sending. Camera data was, of course, depth data is very huge. So you cannot send it through just Wi-Fi and all those stuff. And we were just using wired communication through all the servers. And another challenge we faced is about making the things work all the time. Sometimes what used to happen, a particular sensor is not responding. We have to reset that. And we cannot jump in when the store is open and we go down there and along with the customer fix it. So we had to, what we did is we had some remote login sort of thing to somehow test the cameras or some which is not working, to fix it remotely rather than entering into the store. So these sort of extra software we had to build to handle it.
Great, thank you. So Wael, sort of to you, right? So we were just talking about like security and scale, or maybe I should say security at scale, are kind of the
exactly,
things. How does LoRaWAN help in those scenarios?
Of course. So LoRaWAN is, I think, is a well-thought protocol from the ground up that has embedded security in its protocol layer, like the networking layer. It has also state-of-the-art, I would say, security in the join mechanisms, in the communication from devices all the way to the network servers. So that's AES encryption, AES 128. That's within this kind of state of the art, I would say, in terms of encryption, but also another level of encryption of the data of the application data. So the user or the application data, yeah, I would say the end user controls a piece of the encryption if they want their kind of data to be encrypted with application keys. And the networking piece also, there is like an encryption piece to it. As I was saying, it's a state of the art compared to IEEE 802.15. That's for systems, or 802.11 systems. It's also that's similar mechanisms to what an NB-IoT is actually using in terms of security and key generation and key storing. So everything around kind of the LoRa Alliance was thought from the ground up on the security level and the security at scale. I like that. I would say so. There is also like a question that I see here, if I may, on the Q&A, Dave.
Yeah, go ahead.
Yeah, so there is one that I'm really interested in from Rob, and thank you for that, which is the comparison of LoRaWAN and 3GPP NB-IoT standard. So that's a question that we get a lot, being, I would say, Charter as kind of the operator, and being also part of the LoRa Alliance, and kind of wearing the LoRaWAN, the kind of the LoRa Alliance hat. So I would say the difference is mainly in the business model for these technologies. So there is the technology piece. They are both, I would say, low power weight area networks. So LoRaWAN is more on the unlicensed spectrum, or the license exempt. So anyone who would abide by FCC regulation for the 915 megahertz spectrum can run their own and can own their own network, LoRaWAN network, compared to NB-IoT, where it's the operators of the world that would need to operate that, and will need you need kind of a subscription-based service for that network. So LoRaWAN, I think the advantage of it compared to NB-IoT is mostly on the there are a lot of things that we can talk about on the technology side, which are like it's greater range, it's better in power consumption, it's kind of well thought and better thought in terms of like the adaptive data rates as well, that you can run a network in a kind of a more intelligent way. But the point I want to kind of emphasize on here is the kind of business model for deployment. So an enterprise can build its own LoRaWAN network and manage it, and really kind of relating to the question on security a bit earlier, can manage all the security aspects around the LoRaWAN network and the edge compute and the cloud, and have, I would say, full control end-to-end of the data, from the generation to storage to processing locally on the enterprise side. While on the NB-IoT, you'll always need that operator in the loop. And that might not suit or serve some of the use cases. Also, like thinking and tying, I would say that question back to the theme today. LoRaWAN can be also very like a very compelling technology for edge compute, because you can have all your network basically in a box, kind of managed by your IT, storage, data processing, everything local. NB-IoT, on the other hand, you're pushing data to your to kind of a cloud first, and then retrieving it from your operator. So that's also maybe not kind of the best venue for edge compute and edge applications.
Yeah, thank you. And I think you bring up a really good point. I mean, it's easy for us to get super excited about the technology, and it's important, right? We need to understand it. We need to know the differences. We need to know which one to pick in the right circumstance, all of that kind of stuff. But the fact that you brought up the business side, I think, is also equally important. I mean, certainly one of the things that I believe is kind of universally known after the original first wave of IoT kind of deployments came out of there is that so many of them got stuck in this sort of POC and pilot phase and never made it to widespread deployments for lots of reasons. And certainly one of them is around costs. And it's one thing to say, is it feasible? But the second question is like, is it viable? And so Deepanjan, we were talking about this in preparation around one of the things that you kind of already touched on, but I wanted you to expand a little bit more around, one of the things that, like, if you just had a 2-tier model, let's say, where it's like, I generate all the data here, and then I move it over here to like understand something, that's an expensive proposition. And edge computing provides some ability for you to improve that and make it more economical. Can you share some of those experiences and what you were doing? I think you started talking a little bit about it earlier.
Yeah, surely. So when another thing, the cost effectiveness of the technology of IoT right now, another thing what we faced whenever we ask for any IoT sensor, whether it is a weight sensor or it's a temperature sensor or anything which we are trying to build up, and if we need that, we can get it in 10 piece, 20 pieces. That's easily available. Like the load cells we were using for the weight sensors, we are building it up. Now we needed around thousands of load cells. So this is one factor which the cost went up, and as well as the supply. Even if you pick up any IoT device and you want to test or build a POC, you will not need hundreds of it. You will need 5 or 10 pieces, and you get it easily. And there are many sites, including Amazon. But when we go for the bulk, that we need something in production, maybe 1,000. we get a lot of what we found that it's not so easy to get that many number of sensors, because the manufacturers, we need to contact the manufacturers and then place an order, and then they will proceed with it. And it actually adds up to our project time. This is one thing which we faced. And next, the cost. The cost, see, now what you mentioned is that the huge amount of data transcending over the network and then again analyzing. Of course, we need a lot of storage, which is not required. But on the other hand, if we increase the edge computing, still we need to get the cost down, because normally what we think that 10, 15, but when this 10, 15 number goes to hundreds, the cost is very, very important for the particular organization who is running with that project. For example, suppose a temperature sensor. The temperature sensor, we can build it very quickly and we can send the data. And now, if we need around, like in 7-Eleven, there are around 10,000 stores across US, and we need to place just one temperature sensor in each fridge. That means 10,000 temperature sensors. So now, suppose, just I'm giving an example, we need a project to work on it. It will be a roadblock to get 10,000 sensors straight away. So, and the cost also. So what I felt that, now coming to the business point of view of a cashless store, whether the viability, I think, still is a little bit, because we are selling $2 chips sitting on a $100 plate. So the business always says, yes, we have proved the technology, it works, but it is not going to be the talk of the town, or every owner will come and say that we want to convert our existing store to a cashless store. So it won't happen until the overall cost of everything, not only the network, the sensors, also come down to a very limited level, very minute level, and then it can be used widely. That's what I feel.
Yeah, so that might be a good segue. I'm going to go look at one of the questions and pose it to both of you to see. In fact, maybe all three of us can kind of respond to this, because I think we might have different answers depending on our perspective. So one of the questions was around this idea of offloading or reducing cloud level analytics as an edge goal. And today, I guess the question is where are we in terms of that maturity? Is it I guess the guy gave you three options, right? So number one, is it a done deal, or is everybody doing this? Is it a work in progress, or does it feel far off? And aside from that maturity level, kind of what is needed in terms of connectivity and processing in this regard. So Wael, I mean, where do you see edge-based analytics today in terms of adoption?
No, that's a very good question, actually, and I think we're getting there. I mean, it's work in progress. We're getting there. As I was saying, I kind of tie to where I actually started, which is when I talked about the two types of edge, or what I feel that there is like two types of edge. That's the first step, I think, towards making true edge analytics that's a step towards kind of making that kind of happen. When I said, for example, there is like a true edge and there is like a near edge, and on the true edge, you generate data and you process data and you take decisions. And like if we want some kind of a concrete example, say we have a vibration, LoRaWAN, for example, vibration sensor on a piece of machinery that's kind of constantly supervising that machinery, and it's kind of running a tiny ML or a tiny machine learning algorithm at the sensor itself, and that sensor will decide to either transmit if it detects anomalies, or just ignore that. I mean, the use, like the normal behavior is ignored, or is just kind of updated once a day. And the sensor will be able to kind of trigger itself and trigger, I would say, transmissions when it detects locally. It makes the decision locally that there is an anomaly with the machinery that is kind of being supervised. So that's an example where a true edge, like where we generate data and exactly where we process data. And the near edge would be in a context, for example, of a LoRaWAN or a private LTE or a private 5G, where you have, for example, a factory, and you have it's something that actually we worked on here at Charter, and it's somewhat similar to the use case that Deepjan was talking about, but it's more kind of a factory use case where you have like cameras overlooking for safety reasons, I would say, overlooking the workers in a factory and trying to understand if there is a near miss scenario. So we're trying to see if the kind of a worker is coming extremely close to a saw, for example, or to a kind of a dangerous situation. And for that, the edge compute is not really kind of a true edge, but it kind of is a near edge, because all these cameras are pushing kind of through high-speed connectivity, like private 5G or like Wi-Fi 6, all the kind of feeds, and this is being processed at the infrastructure level, like where the, as we said, where the network in a box is, and everything kind of, that box would have all the analytics, all the machine learning, all the computer vision to understand the scene and to process locally in near real time, actually the information, rather than pushing everything to cloud and being, I would say, and push all the video to cloud. Actually, when we did even some of the math, when you process locally, your I would say near real time, you instantaneously can catch these near I would say near miss scenarios, comparing to when you send things to cloud. By the time you send your video feed, the high quality one, to cloud, processing it and coming back with a decision, that's at least 5 to 10 seconds of delay, and the worst might have happened while you're trying still to see what's going on with that video feed. So I think we're there. And I think I would say this is actually a great question, because we're getting there. We're deploying more and more kind of capabilities in the edge, and that's why I think the edge, or actually IoT in general, is it's an edge play, and whoever is going to combine machine learning, edge computing, and the right connectivity solution in one box is going to win that game, I guess.
Yeah, Dipanjan, what's your view on that sort of, where things are at in terms of analytics on the edge? Is it mainstream, or is it still just being, sort of viewed as a future thing?
What I feel is that, as he said, that similarly we were tracking this. We did not go for the cloud for these video footages, because, as he said, 10 seconds, it was actually practically, we would have missed a customer picking up an item and moving out or putting it back. Maybe we would have missed it. So sending everything to the cloud, I don't think it's for these type of projects where continuous tracking thing happening with vision, computer vision. Now, if we can, what he is saying is absolutely what is the need today, that everything in a box, the network, the machine learning, and whatever logic we are putting, our business logic, if we put it in the box with the edge, every camera is intelligent enough and it will process very fast, and then it will only send maybe the required data to the cloud. So for most of this, our project, we did not go for the cloud. We actually had everything in-house to catch up with the speed.
Great. And I guess my answer to this question would be the it depends type of answer, because I'm glad the question was asked into the context of analytics and not necessarily specifically AI, because I think that depending on the industry and use case, you do see some variation. So I know there was another question about like industrial IoT. And I would say that when I see what's going on in industrial IoT at the edge, I wouldn't say it's full-blown AI models running on the edge necessarily. I think there's a lot of machine learning being applied to large data sets, and then certain rules and not business knowledge being pulled out of that and then being deployed sort of at the edge in a rules engine sort of way. So it's, you are using analytics, but it's not necessarily that full-blown closed loop AI model. But then if I was to look at some of the examples we were talking about around like video analytics, like object detection, and even like behavioral analysis and stuff, that is actually happening today. And then I think there's the future stuff like, autonomous cars and all the things that are there. So I think even if you break it down, you could probably see a now, a next, and a, maybe, 3 or 4 year down the road before we start seeing that. And I think it's the good and the bad about edge computing, right? It's not a one singular concept. I think it's how the mentality is applied of saying, you don't always want to centralize what you're doing. You want to distribute it, and you want to do it in a way that's easy to manage and easy to deploy, I think is really important. So with that, I think we've come to the end of our time for this panel discussion. I would like to extend my thanks to Wael and to Deepanjan for sharing both your knowledge and your experience. And I think, as Sean mentioned earlier, we'll do our best to try to get back to any of the questions that we couldn't answer in this session. So Sean, back to you.
Hey, Dave, Sean dropped, so let's just end it here, okay?
Oh, okay. So, all right. That's great. Thank you, everybody, for attending. And I hope you look forward to the rest of today's content.
Great.
Thank you.
Awesome. Thank you so much. Thank you, Dave, Wael, and Deepanjan for your insights. As we end our session, I'd like to invite our audience to join us in the exhibit hall for our networking break. And you'll also find resources from all of today's sponsors. So let's keep the conversation going. Thank you, everyone, for attending this session. And within the next 24 hours, you will receive a follow-up email with details and a link to today's virtual event presentations on demand. Up next, be